the term we use on how we actually name molecules and compounds, etc. Okay? So, with organic chemistry, because we're going to go into different types of molecules, we're not always going to have them this simple, you need to be able to know how to name them. So we start off with the basics. So with all alkenes, you start off with the number of carbons as your prefix, and then the suffix for alkanes will always be in ane. Okay? So let's practice with them, with one, okay? And then I'm gonna look into the difference between a structural formula and a molecular formula and an empirical formula. So choose one that's not a methane.
Propane.
Let's try with heptane. And then we'll do propane later. Okay, so heptane tells me how many carbon atoms?
7.
Okay, now the trick here is always start off with your carbons and leave the hydrogens till the end.
Miss Wait, what are we doing?
We are drawing the structure for heptane. We are drawing the structural formula for heptane. So I start off with the carbons. So I count 1, 2, 3, 4, 5, 6, 7. Now we're going to start off with a straight chain. Sometimes you get branches, but we'll talk about that next lesson. Okay? So we start off with the carbon. They're all in a row. And you'll notice that they all have single bonds because this is an alkane. Okay? Never draw double bonds and triple bonds in an alkane. Okay. So Mariam, I need to look at all of the carbons and make sure that they have 4 bonds around them. Okay? So I want you to start with this outer one. How many bonds does it already have?
1.
1. So how many more do I need?
3.
3. So then I would have 1, 2, 3. Jana, look at this carbon here. How many bonds does it already have? 2. So how many more do I still need?
1.
To get to 4? So 1, 2. Okay? Always count your bonds. They always have to have 4 around the carbon. Okay? What about this one, Yasmin? Okay, so you'll see that the middle ones are going to be repeating by a factor of CH2, correct?
Yes.
And then we get to the last one. How many hydrogens will that one have? 3. So this is 1, 2, 3. So this is called a structural formula. From the name, a structural formula tells me everything I need to know about the molecule. It tells me how many atoms. It tells me if it's single bonds and how is the arrangement around them. Okay? Badriya, if I ask you for the molecular formula for this, what would you say? I need the molecular formula.
The C. 7.
Perfect.
What?
H. H.
16. 16. H. 16.
H16. Let's double confirm. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Well done. So this is called the molecular formula. Okay? And this thing here is called the structural formula. Now if I ask you, is the molecular formula an empirical formula?
Yes. What?
Why is it an empirical formula?
Because you can't break it down or something.
Excellent. I can't simplify it into smaller bits because 16 doesn't go into 7. Okay? So, you wouldn't be generally asked for an empirical formula, but you need to review anyway. So, this is called the structural formula, and this is called a molecular formula. Okay? So, what I want you to do in your papers right now, in your notebooks, for each of these, write the name, draw the structural formula, and write the molecular formula. Then, I want you to come up with a general formula for all alkanes. Is there a general trend? Every time you go down, what are you adding? And by what factor? And what is the ratio of the carbon to the hydrogen? Is there a link between 7 and 16? Can you come up with a general formula? Look at it, yes. Go. Make a mathematical operation.
You had a diagram.
Okay?